So in this video, we're going to take all of the operations on rational expressions and put them together. And the way that we do this is we work with something called complex fractions. So in complex fractions, we have fractions within fractions. And we talked about this in some of the prior videos. So you're not going to be completely unfamiliar with it. Okay, so what's an example of it? Let's say that we have 3 over 4 divided by 2 over 3. Okay, so we talked a little bit about this when we were dividing. And we said, okay, well, this is a complex fraction because we have a fraction within a fraction. So how do we get rid of this? Well, in division of fractions, we said we get rid of this by multiplying by the reciprocal of the bottom. But we have to do that both on top and on bottom, both in the numerator and the denominator, because we don't want to change the value of this expression. But now we don't have fractions within fractions. This just gives us 3 over 4 times 3 over 2, or 9 over 8. Okay, but this can be a little bit more complicated than just one fraction over another one fraction. So let's take an example where we have more than one fraction. Let's say that we have 2 plus 5 over 6. Over 1 minus 7 over 8. Okay, well, this seems more complicated, right? Well, the idea is that what you're going to do first is just use all of the operations, okay? So here, we're going to use addition to combine the fractions on top. We're going to use subtraction to combine the fractions on bottom. Then we're going to be dividing one fraction over another fraction, which leads to multiplication. So in other words, our goal is to get it to look like this, where we have one fraction divided by another fraction. One fraction in the numerator, one fraction in the denominator. Okay, well, how do we do this? We can work with both the numerator and the denominator simultaneously. First of all, when you see a whole number, put it over 1. Okay? The reason for doing that is just because we're dealing with fractions and it makes it a lot more visually pleasant if you have fractions all the way through, okay, instead of your whole numbers. Also, in terms of finding a common denominator. So here, our common denominator, we can multiply on top, we can multiply the first fraction by 6 over 6. Second fraction doesn't need to be multiplied by anything. And on bottom, we can multiply the first fraction by 8 over 8. Okay. So what does that give us? Sorry, I'm trying to find my mouse. Okay, that gives us 12 over 6 plus 5 over 6. And then on the bottom, we get 8 over 8 minus 7 over 8. Okay, well, now we just add, right? So we have 17 over 6 over 1 over 8. From here, We have one fraction over another one fraction, so we multiply by the reciprocal. And we get 17 over 6. Times 8 over 1. And if you're good at your numbers, you can see that you can divide both the 6 and the 8 by 2, and you'll get 17 over 3 times 4 over 1. But if you're not that good at it and you would prefer just multiplying and then reducing, okay, then you're going to get 136 over 6. Which is the same thing as 68 over 3. Okay. So your ultimate goal is to get a single fraction over another single fraction. In other words, one fraction in the numerator and one fraction in the denominator. So here, what did we do first? First thing that you do is you find a common denominator for the numerator. And find a common denominator for the denominator. Okay, so that was your first thing that you did. Second thing, we combined the fractions. Meaning add or subtract. That came here, okay? The middle step, the 12 over 6 plus 5 over 6, over 8 over 8 minus 7 over 8 was still part of the process of finding the common denominator. And then the last thing that you did is we multiplied, and I'll just put a note here, the result, this is always going to be true, is one fraction in the numerator and one in the denominator, which is our goal. Because from there, we're multiplying the numerator by the reciprocal of the denominator. And we're going to do two examples of this, just combining these fractions so that we do reach this ultimate goal. I'm only doing two examples, one, to make this video a little bit shorter, but two, because we've actually already done all of these things, okay? We already know how to add. We already know how to subtract and multiply and divide. Everything that you see on the screen here, we've done before. All we're doing is putting it all together, okay? So let's take the first example. Okay, and this is meaning working with algebra. So let's say that we have 1 plus 1 over x plus 3. And then we're dividing by 1 plus 7 over x minus 3. And we're just going to follow these three steps that we have. So first thing is I would put your whole numbers over 1. Okay. Okay. What you're going to do is you're going to find a common denominator for the numerator and a common denominator for the denominator. So in the numerator, we have 1 and x plus 3. We look at the first fraction and we say, what does the other fraction have that this one doesn't? The other one has an x plus 3. This one doesn't. So we multiply by x plus 3 over x plus 3. Now, when we go to the second fraction, we say, what does the other one have that this one doesn't? The other denominator is just 1. So we're not multiplying by 1 over 1. That doesn't do anything. So now we do the bottom. What does the other denominator have that this one doesn't? An x minus 3. And then if we look at the other fraction, again, the first denominator has a 1, doesn't do anything, okay? Okay, what comes next? Well, let's continue this and just multiply out the top and the bottom, okay? So we have x plus 3 over x plus 3. And I actually should relabel this because I never put a 2 here, right? The 2 is over here when we actually multiplied out the numerators, where we combine like terms. And the 3 is here. Actually, this is just a matter of, this isn't really confusing. It's just a matter of labeling these so that it makes sense. So here we found the common denominator. Here we combine like terms. So I'll keep this as a 2. And our 3 is really here. I never wrote the 3. Okay. Coming back down here. Sorry about that. X plus 3 times 1 is just x plus 3 over x plus 3. And then plus 1 over x plus 3. On the bottom when we do it, we have x minus 3 over x minus 3. Plus 7 over x minus 3. And I should put that in red. I'm just rewriting the exact same thing, just in red. And I do that just so that when you see the notes, you can follow along clearly as to what's an example and what's the work. So this is over x minus 3 over x minus 3 plus 7 over x minus 3. And now this is where step 2 comes in, when we combine our like terms. So x plus 3 plus 1 is x plus 4 over x plus 3. And then x minus 3 plus 7 is also x plus 4 over x minus 3. So this is our step 1, really both of these together. This is our step 2. And now our next step is going to be our step 3. And what that is taking the top and the bottom and multiplying by the reciprocal of the bottom. So the x minus 3's cancel, the x plus 4's cancel, and we do the same thing up here. Notice it's x minus 3 over x plus 4, so you're multiplying by the same thing on top and bottom, which leaves you with x plus 4 over x plus 3 times x minus 3 over x plus 4. And notice what's happening here. The x plus 4 cancels both on top and bottom. And what are you left with? X minus 3 over x plus 3. And that's it. That's your final answer. Okay, let's do another problem. I'll actually do 2 more, just so that you really two more. The next one is just a little bit different because in the next one, you're not going to be required to add and subtract. Okay, so it's just going to be a matter of simplifying. So let's say that we have 3x plus 1 over x squared minus 49 over 9x squared minus 1 over x minus 7. Okay, I want to emphasize this is just a division problem. I just want you to see that if there is no addition and subtraction, then it's just division. Okay? So we can just multiply the top and the bottom by the reciprocal of the bottom. So what does this give us? 3x plus 1 times x squared minus 49 times x minus 7 over 9x squared minus 1. So now you factor. 3x plus 1 can't be factored. X squared minus 49 is the difference of squares. X minus 7 can't be factored. 9 squared minus 1 is also a difference of squares. So the 3x plus 1 cancels. The x minus 7 cancels. What are we left with? Well, everything canceled in the numerator. So we are left with a 1 in the numerator. So this is just 1 over x plus 7 times 3x minus 1. Okay. If there is no addition or subtraction of fractions in the numerator, there's not all of a sudden going to be addition and subtraction. Okay. Also, if you see plus signs never go away completely. Okay. So you can, and I mean within your terms. So 3x plus 1, you're going to have a 3x plus 1 over here. So we factored. We multiplied the numerator by the reciprocal of the denominator. And then we canceled. Okay, we did it actually in the opposite order. We multiplied by the reciprocal of the denominator, and then we factored, and then we canceled. Okay, one last example, and this one will be, so that's a complex fraction. It's just not as complicated as the one before. Let's do one last one that is as complicated as the first. So let's say that we have 4 minus 1 over x squared divided by 4 over x sorry, hang on one second. I just want to make sure over 4 plus 4 over x plus 1 over x squared. Okay, what do we do here? Same exact thing. Put your constants over 1, right? Your whole numbers over 1. So make this 4 over 1 and make that 4 over 1. And then find a common denominator. So first fraction, what does the other one have that this one doesn't? It has an x squared. So we're going to multiply by x squared over x squared. At the bottom, is it trickier because there are 3? Yeah, but not much trickier. Okay, you're saying what do the other 2 have that this one doesn't? Well, this one has an x. This one has 2 x's. So we don't need to include 3 x's. We only need to include 2. Because if we include 2 x's, if we make this x squared over x squared, then it already includes the x that's in the second denominator. And now we're going to the second. We're saying, what do the others have that this one doesn't? Well, this has 2 x's. This only has 1. We need to give it 1 extra x. So we're going to multiply this by x over x. And then this one doesn't, it already has 1x. So we don't need to multiply by anything. So what do we get here? We get 4x squared over x squared minus 1 over x squared. Notice we have a common denominator now. Then we have a 4x squared over x squared plus 4x over x squared, and then plus 1 over x squared. Okay. We can combine our fractions. We get 4x squared minus 1 over x squared divided by 4x squared plus 4x plus 1 over x squared. So let's just take a quick review here, what we just did. These are really just the first two steps. So just because this is written tightly, let's just review. Finding a common denominator. What does the other fraction have that this one doesn't? The other fraction has an x squared. This one doesn't, which is why we multiply by x squared over x squared. What do the other fractions have? So now it's plural. There are two other fractions. Well, one fraction has an x, the other one has an x squared. The x squared already includes this x. So if we multiply by x squared over x squared, that's enough. What do the other fractions denominators have that this one doesn't? Well, here that's just a 1. That's included in anything. This is an x squared. That means this has 1x. This one has 2. So we add the extra x by doing times x over x. Okay, so we put in an x squared. Essentially what you're doing is you're saying, well, x squared is the common denominator. First denominator, first fraction gets multiplied by x squared over x squared. Second fraction gets multiplied by x over x. Third fraction, we don't have to multiply by anything at all. And then we just combine like terms. From here, we're going to multiply by the reciprocal of the, so this was all step 1. This was all step 2. And now we're on step 3. We're going to multiply both of these by the reciprocal of the denominator. X squares cancel. And you could cancel them here or you could cancel them afterwards. I just canceled them here. So what are we left with? Four x squared minus 1 over 4x squared plus 4x plus 1. Okay, can we reduce? The answer is yes. 4x squared minus 1, and this is a case where you have to factor. You're just not going to know otherwise. 4x squared minus 1 is a difference of squares. It's 2x plus 1 times 2x plus 1. Sorry, times 2x minus 1. If we factor, (4x squared plus 4x plus 1), you're using the a times c, right? A times c is 4 times 1. We need two numbers, which is 4. We need two numbers that multiply to 4. And two numbers that add to 4. And we know that both of those are 2. Okay, so that's going to give us 4x squared plus 2x plus 2x plus 1. Factor out a 2x. And we're left with 2x plus 1. Since you can't factor anything out, you just put a 1 in front of it. Pull out the 2x plus 1. What are you left with? The 2x in front of the first set of parentheses plus the 1 in front of the second. So this factors to 2x plus 1 times 2x plus 1. 2x plus 1's cancel. We get 2x minus 1 over 2x plus 1. And this here is our step 3. Okay. The only thing that made this a little bit more complicated was the fact that you had 3 fractions on the bottom, but their denominators were pretty straightforward. So, right, if you have an x and an x squared is always going to be your lowest common denominator. And that's it. The last thing that we're going to have with rational expressions is just equations, and then we're done with those.